Assalamualaikum and hi everyone. Okay, here we will going to do a presentation under the topic trigonometry in architecture. Let me introduce our team members.
Hi, I'm Huda, matrix number 08DEU22F1016.
Hi, I'm Amira. My matrix number is 08DEU22F1099. Hi, I'm Ayuna Bila, matrix number 08DEU22F1078. Hi, I'm Shahira. My matrix number 08DEU22F1062.
What is trigonometry? Trigonometry is a branch of mathematics that deals with the study of triangles. It is sometimes informally referred to as trig in trigonometry. Mathematics study the relationship between the sides and angles of triangles. Right triangles, which are triangles with one angles of 19 degrees, are a key focus of study in this area of mathematics. Trigonometry builds on basic math concepts learned in lower grade levels, and it can be a confusing subject to navigate. Thank you.
Basic history of trigonometry. The word trigonometry comes from the Greek words trigonon, which means triangle, and metron, which means to measure. Until about the 16th century, trigonometry was chiefly concerned with computing the numerical values of the missing parts of a triangle, or any shape that can be dissected into triangles when the values of other parts were given. For example, if the lengths of two sides of a triangle and the measure of the enclosed angle are known, the third side and the two remaining angles can be calculated. Such calculation distinguish trigonometry from geometry, which mainly investigates qualitative relations. Of course, the distinction is not always absolute. The Pythagorean theorem, for example, is a statement about the length of the three sides in a right triangle and is thus quantitative in nature. Still, in its original form, trigonometry was by the large offspring of geometry. It was not until the 16th century that the two became separate branches of mathematics. Application trigonometry in architecture. Trigonometry is what helps the architect to calculate roof slopes, ground surface, light angles, structural loads, and height and weight of structures to design a mathematical graph that a constructor can use for construction purposes. Trigonometric functions are what helps in drawing angles, calculating position, measurements, and determining the height of the structures. With the help of various trigonometric functions, an architect elucidates a designer's plan that can be easily understood and used by construction. Trigonometry used in architecture include arches, domes, suspension bridge.
I'm Huda, matrix number 08DEU22F1016. So today we're going to proceed with trigonometry formula. Since as we know, basic trigonometry formula, sin, cos, tan. In a triangle, we have opposite, adjacent, and hypotenuse. Sin theta is equal to opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. Cosec theta is equal to 1 over sin theta, and it's equal to hypotenuse over opposite. Sec theta is equal to 1 over cos theta, and it's equal to hypotenuse over adjacent. cot theta is equal to 1 over tan theta and equal to adjacent over opposite. But what if the triangle is not in 90 degrees? For example, like obtuse angle or acute angle. So, the solution is we need to use sine and cosine rules. Alright? So, consider the triangle ABC where angle A is opposite to side A, angle B is opposite to side B, and angle C is opposite to side C. We're going to start first with a sine rule. Sine rule, for the formula to finding length and angle is A over sine A is equal to B over sine B is equal to C over sine C. A is a side and the sine A is an angle. Alright? So for the case 1, if the question given 2 angle and 1 side, right? We can use to find length or angle using a sine rule. For the case 2, the question will be given 2 side and 1 non-included angle, not angle between the 2 angle, the 2 given sides are given. Okay, so you can use the sine rule to find length or angle. Formula for cosine rule to finding length is S square equal to B square plus C square minus 2BC cos A. For finding angle, cos A is equal to B square plus C square minus A square over 2BC. When we are going to use this cosine rule? Okay, we need to use a cosine rule if the question is given 2 sides and 1 angle. In the other cases, only 3 sides are given. So, in this case, the angle between the 2 given sides are given can be used for the cosine rule.
So now, let's try some questions. So for the first question, we were asked to find the length of the side AB. We have 2 methods here to find the value of x. The first one is by using the very basic formula of trigonometry, which is sine equal to opposite per hypotenuse, cos equal to adjacent per hypotenuse, and tan equal to opposite per adjacent. So, if you look at the picture, the information given to us is angle C is 60 degree and the length of BC is 50 meter. So, from the figure, we can use basic trigonometry formula, which is tan equal to opposite per adjacent. So, tan 60 degree equal to x, which is the opposite, over 50, which is adjacent. Then we bring the 50 to the other side, and the equation will be x equal to 50 multiplied by tan 60 degree, and for the answer, you will get 86.6 meter. Okay, so this is the first method, and for the second method, we can use sine rule formula. We already know the value of angle C and B, so we just find the angle A. The total angle of triangle is 180 degree. So to find the angle A, 180 degree minus 90 degree and 60 degree, and then we get 30 degree for angle A. So now, just put the values in the formula, which is A over sine A equal to C over sine C. And then we bring the sine 60 to the other side. And by using the calculator, you will get 86.6 meters, same as well as the first method. Let's move to another question. Question 2. From the top of the Eiffel Tower, a jogger is spotted heading toward the tower. At 2 p.m., the angle of depression of the jogger A was measured to be 37 degrees.
4 minutes later, B, when measured again, the angle of depression had increased by 35 degrees. Find the average speed of the jogger to the nearest foot per minute. Okay, highlight here. The question asks to find the average speed of the jogger to the nearest foot per minute. Okay, so for this question, it also have two methods as well as the first question, but I will explain one method only. We can use the first method because it's very simple rather than the second method. First of all, we need to find the length of AC. We can use the ADE triangle. You can notice that the length of DE is same as AC. Same goes to EA and DC. So, we can use formula tan 37 equal to 986 over AC instead of DE. And then, we will get the answer for AC is approximately equal to 1,308.466 feet. And then, we need to find the length of BC. So I draw another diagram and put a new line between the F and B. Then we can get new triangle to find BC. From the new diagram, we can get tan 72, which is 37 plus 35 equal to 986 over BC. So for the answer, you will get BC is approximately equal to 320.37 feet. So then we already know the length of AC and BC. So we can get the length of AB is approximately equal to 988.069 feet. The question asks to find the average speed to the nearest foot per minute. So that's why we need to find AB. Then AB divide by 4 minutes and you will get the final answer is 247.024 foot per minute.
The conclusion is, we realize that trigonometry can be used in many areas such as astronomy and architecture. They can aid in calculating many things. They can also be used in cars, desks, and benches without really climbing a tree. You can find the height easily with trigonometry. They can be so widely used in real-life application and is very useful for most architects and astronomers. We can conclude that without trigonometry, life would be much more difficult. Without going through the troubles, you can easily find something, so we think that it was a good invention by Archimedes, and thanks to this many architects do not need to go through the trouble to calculate things. So it really helps in real life application and not only in our tests and exams. Thank you.
I hope you guys understand our explanation just now.
Thank you for watching us.